Do some at recess.
Okay, so hi everyone, welcome. Today we're talking about increasing and decreasing. So to begin with, we're just going to start off by what we mean by increasing and decreasing, and then we're going to get into how we can use some calculus methods to do it. So you'll notice this isn't in your notes book. That's because this is question 1 of exercise 15C. That's what we're doing today. And so I thought I would just like to go through this one with you guys together. So if you can pull out, we're going to need our workbook, we're going to need our notes book, and this is from the textbook, this is from 15C. So if you're going to open all that up, and we'll go through this first problem together. Okay, so this is our first one, isn't it? This is the first question they have there. And the way we tell if a function is increasing, right, is what you've got to imagine is that you're standing on the function and you're walking along it. Always moving from left to right, like how we read a book, okay? And you're going to go, am I moving up or am I moving down, okay? If you are moving up, then you're increasing, all right? So what we can see here is that the function starts when x is 0, y is 3, x is 0, and then you're just going to keep increasing forever. So for this one, we're going to say increasing for, just like how we describe domain, x is greater than or equal to 0. All right? It's increasing for all values of x that are greater than 0. It is never decreasing. Get to the second one. And that point is minus 2, 2. Okay, what we can see here, okay, we start at the leftmost point and we imagine that we're walking along it. We can see we're walking down the whole time. And so this is going to be decreasing, and then we're just going to state the interval over which the function exists. So this is, again, going back to a little bit of domain range, it's decreasing from x is minus 2. We're not including that point, so I'm not going to underline it. And then all the way up to positive 3, and we are including that point. It's decreasing over the whole interval of the function. Okay, most of the ones that we deal with are going to be a bit like this one. Okay, so we go to the leftmost point, you know, we can see here that's sort of going down forever, so we can imagine over this period we're going to be walking up the hill. We get to the top, okay, so it's increasing until we get to x is 2, and then it's decreasing for values larger than 2. So for this one we're going to say increasing, okay, that is you're walking upwards when x is less than or equal to 2. Okay, we always go for that x value. And then it's decreasing when x is larger than 2, larger than or equal to 2. Now you'll notice we always include the point when we're talking about an interval over which we're either increasing or decreasing. Okay? All right. The third one. Okay, so what we can see is it goes horizontal here. Alright, so we have sort of a horizontal slope there. So it's increasing, it goes horizontal, and then it keeps increasing again. We're still going upwards. So what we're going to write here is it's increasing for x is less than 0. Okay, it's increasing over that period. It's horizontal at 0. And then it's increasing for x is greater than 0 as well. That's how we need to answer that. Okay? All right, what we can see with this one, We're walking downhill, we're decreasing until we get to 1, and then we're increasing between 1 and 5. It's increasing, you're walking up the hill, and then you're decreasing for values larger than positive 5. So what we're going to write, okay, is we're increasing, what is the interval over which we're increasing? Between x is 1 and 5. And we're including both of those points. And then we're decreasing, okay, you're walking downhill for values x being less than 1, comma, so we're decreasing over that interval, and then we're decreasing over this interval as well, which is x is greater than 5. Okay, so decreasing for x is less than 1, increasing between 1 and 5, and then decreasing for values less than 5. Okay, last one here. And then there's an asymptote at x is 4. Okay, so we'll just start at the left, and what we can see is it's decreasing, and then there's an asymptote at 0, okay? Because although it's not strictly there, okay, we can see it's going that way forever and up that way forever, so there's an asymptote at this point. So what that means, when we think of decreasing, we're going to say it's decreasing for values less than 0. And we don't include the point because it doesn't exist at 0 because there's an asymptote there. There's an asymptote there. So it's decreasing for x is less than 0, it's decreasing there. And then it's decreasing here as well. Okay, you're still walking downhill over this interval until we get to 2. Okay, so that's going to be decreasing for x is 4, 0 is less than x less than 2. So between 0 and 2, over that interval, we're walking downhill. And then it's going to be increasing. All right, we're limited on space here. Increasing for values between 2 and 4. There's an asymptote there. If you're going from 2, this is going to keep going up. Okay, there's an asymptote there. So between 2 and 4, we're including the point 2. I should include it here. Here. We're including the point 2 because it exists at that point. We're not including 4 because there's an asymptote at 4. And then the last one is it's going to be increasing for values that are larger than 4. This asymptote is at x is 4, so it's going to be increasing for values larger than 4. Okay, that last one's a tricky one, all right, because of the asymptotes and so forth. But you just start from the left, you can see we're decreasing for values less than 0. That's a true statement. We're decreasing between 0 and 2. That's a true statement. We're increasing between 2 and 4, and then we're increasing for values larger than 4. Okay, so that's what you're doing here. Okay, that's how we can know when a function is increasing and decreasing from looking at the function. Okay, so to solve all of these problems, we could just look at the graphs and determine the information from the graph. But we want to use some calculus techniques. Because what do we notice here? What is increasing or decreasing but when it has positive slope? Okay, so the slope is going upwards, and negative slope, so the slope is going downwards. And we know that in calculus we're finding the slope function. Okay, so we're going to combine a few things that we've learned here. So I'm going to spin it around. We've sort of done the first exercise there. And let's pull our notebook out now and we'll address the questions in our notebook.
So just one slide. But then do it for the room. Most
likely. Okay, very good. So that's going to be our process. So our first problem is the function x squared plus 6x take 5. Okay, and our task is to find where the function is increasing and decreasing. Okay, so the first thing we could do is We could just graph it, right, and get the solution from the graph. Okay, so here I've got the graph on Desmos there. Here, this is the function, x squared plus 6x take 5. And so what you can see is it's decreasing, okay, it's decreasing all the way down here until it gets to x is minus 3. And then it's going to be increasing. So we already know the answer just from looking at the graph, but we're going to use calculus methods to demonstrate the answer. Okay, so let's leave that as it is for now. We already know the answer, but let's use those calculus methods. So here's our process. Find f dash of x. Okay, so if this is f of x, we're ready to differentiate straight away using simple differentiation. That's going to be 2x plus 6. Okay, step 2. Draw a sine diagram of f dash of x. Okay, sine diagram, we did them in semester 1. Let's do a quick recap of those. What a sine diagram is it's an indication of where the function is positive and where the function is negative, when it's above the x-axis and when it's below. So in order to draw the sine diagram, I need to draw the graph. Okay, if I think of the graph of 2x plus 6, now you can graph this on your calculator, okay, but let's try and think about it, how we would graph that. It's the equation of a line, okay, y equals mx plus c, okay? So that means our y-intercept is positive 6. That's going to be the y-intercept, and it has a slope of 2, which means as x goes across 1, y goes up 2, across 1, up 2. So it's going like this, it's got positive slope, and it's going to look something like this. We need this x-intercept of the line though, okay, for the graph, the x-intercept. The x-intercept occurs when y is 0. Remember, this is the equation of a line, y equals mx plus c. The x-intercept is going to occur when y is 0. So that's going to be minus 3. This point here, x is minus 3. Okay? So that's the graph, and I've just drawn that manually. And now we're ready to draw the sine diagram, okay? Because a sine diagram is a horizontal line, and on the sine diagram it has the roots, okay? The root of this function is minus 3. And then we're just going to indicate where is it positive, where is it negative. So what we can see is for values less than minus 3, it is below the x-axis, it's negative. And for values larger than minus 3, it's above the x-axis, it is positive. Okay, so let's just look back at our process. Find f dash of x, done. Draw a sine diagram of f dash of x. So in order to do that, I did it all manually, okay? Nonetheless, you can rely on your calculator, okay? And so you could graph the function, the derivative function, which is 2x plus 6. Okay, that's the function there. That's exactly what it looks like, isn't it? And you can get from the graph the sine diagram. Okay, you could look at this graph and draw the sine diagram of it. That's the root. All right, so you can use technology here to help you out, particularly for some of the harder ones. Okay, if it wants to, we're not testing you on this manually, okay, but we're just making those connections for you. Okay, so we've drawn the sine diagram. Next, state the intervals when f of x is increasing. Well, let's look at this, okay? F of x is the function. F dash of x is the slope function. That means it tells us the slope. And so what this is an indication of, this is the sine diagram of f dash of x. It's the slope function. It's telling us when, this is the revolutionary part, it's telling us when the slope is positive and when the slope is negative. If we have positive slope, it's increasing. If we have negative slope, it's decreasing. And so we're going to make our increasing, decreasing statement from this sine diagram, okay? It's going to be decreasing when the f dash of x sine diagram is negative. So that's going to be for values less than minus 3. It's going to be increasing, okay? That's when our f dash of x sine diagram is positive. So for values larger than minus 3. Okay, and we've answered the question using calculus methods. We found the slope function. We can see when it has positive and negative slope, and so that's when it's going to be increasing, decreasing. Okay, so let's try and make the connection there. All right. The red one is the function, okay? And what you can see is it's decreasing until we get to -3. All right, that's important because the blue one is the slope function. And what you can see is it's below the x-axis until it gets to -3. What that means is f of x has negative slope until it gets to -3 because the slope function is below the x-axis, okay? Then it gets above the x-axis. And over there we've got positive slope because it's above the x-axis. So that means this function is increasing. Okay, our next question is the line 3x. I might spin this board around actually. 3x take 4. This is going to be a nice short one. Okay, we have the line y equals 3x take 4. Now this is one that you could just answer by looking at it, like if you were to theorise a bit about it. This is the equation of a line. It has a slope of 3. That means the slope's not changing. It means it's got positive slope for the whole thing. So that means it's going to be increasing forever. Okay? Nonetheless, let's use the calculus methods. What's our process? Find the derivative function. Okay, dy and dx is going to be 3. Draw the sine diagram of the derivative function. Well, if you're going to graph the line y equals 3, it looks like this. It's a horizontal line, okay? Y equals 3. And if you're going to draw the sine diagram of that function, it has no roots. It is completely above the x-axis. It is always positive. Okay, so this is the sine diagram of dy and dx, which means the original function is always increasing. And so how do we write that? If it's increasing for all values, for all real numbers. X belongs to the set of all real numbers. Okay, last one. Now I'm going to spin this around again so I can refer back to the process because it's more of a complex one. Okay, find f dash of x. This is f of x. It's ready to differentiate. Everything's at the top as x to the f. Let's go. Okay, so here's where we need to draw the sine diagram of f dash of x. So I'm going to remind you how we can do this manually, all right? But this is where you can just jump in, graph this, and draw a sine diagram, okay? So how am I going to do this manually? Well, I need to find the roots. That is, I need to know when is it going to equal 0. So I make it equal to 0. And then to solve this is a quadratic that's equal to 0. We need to use the cross method. So x and x, multiples of -5 that add to 4. That's going to be +5 and -1. Okay, so we can see we're going to have +5x take x, leaves you with +4x. So this factorizes to x plus 5 times x take 1. So they're the roots, okay? X is -5 or x is 1. So I can go, I don't need to draw the graph, I can go straight to the sine diagram. -5 and 1. Okay, and there's one other piece of information I can use to fill this in really, really quickly with quadratic, so you can remember. It's a quadratic. A is greater than 0, which means it's going to be a smiley face. It's positive. A is positive, so the graph is going to be happy because it's positive. So that means it's going to be above, below, above. okay? All right, so step 1, find f dash of x. Step 2, draw the sine diagram for f dash of x, okay? So if you're worried about what we did there, I encourage you to try to do it manually, all right? I encourage you to recollect those skills, but if you're struggling with it, don't worry, okay? Graph that and draw a sine diagram. How would you do that? Okay, I've graphed it up here. We've got x squared plus 4x take 5, and then you can see the roots, minus 5 and positive 1, and you can see that is above the x-axis, below, and then above the x-axis again. Okay, so that's how I'm generating that sine diagram. Okay, now we're ready to answer the question. Remember, this is the sine diagram of the derivative. This tells us when the slope is positive, that's when the function is increasing, and when the slope is negative. So that means f of x is increasing when x is less than minus 5 and x is greater than 1. And then decreasing between those 2 points. Okay? Now do not mix up f of x and f dash of x. Okay? We are using f dash of x and the sine diagram of f dash of x to tell us about f of x. So we're using that sine diagram to tell us about this black function. Okay, so what we can see, the red function is the slope function. So that means when the red function is above the x-axis, that the original function, that is the black function, has positive slope. So look at that. You can see the red function is above the x-axis until it gets to minus 5. Look at the black function. It has positive slope. It is increasing until it gets to minus 5. Okay? And then it's decreasing between minus 5 and 1, which is when the slope function is below the x-axis. So the slope function is negative. It has negative slope. All right. I think I've said that enough. So let's get on with 15c.
You said a is bigger than 0 makes it positive.